Okay, protein channel is a structure, just like a door. Bob. It is like a door. Channel is like the passage through which the ions can move in and out. And facilitated diffusion is a process, the name of the process, how the item or an ion or a protein or anything can leave or can enter into the cell. This is a process. Name of the process is facilitated diffusion. And name of the area through which this occurs is a protein channel. Okay.
So it's the same, right?
Not the same. This is one is the name of person and second is the name of or the characteristic of that person.
Okay, thank you. Doctor,
Yes.
can you do a revision for all the lecture?
All the lectures. I have taken only 2 lectures for the exam one. First, let us
Yes,
finish.
yes.
Yeah. Let us
I
finish
mean
the
your
2. Yeah.
lectures.
Yeah. My lecture, I will finish my lecture. And if you have a specific question in between, you can ask me.
Like doctor, it's the first time for us taking physiology. So can you give us examples of how, like,
Of
in
course. Of
every
course.
how
Yeah.
how
Sure.
the questions will be?
Yeah.
Like
Sure.
we don't get it.
Yeah. Even during the class, also, I told you how the question will be. But again, I will repeat it here. Don't worry. So let me share the slide for lecture number 2. That is transport across the cell membrane. This is my screen and these are the slides. I hope you are seeing my slides now. Transport across the cell membrane. So in this lecture, we we discussed how the things move in and out of the cell. This is the meaning of this lecture. Transport across the cell membrane means how the things move in and out of the cell. What are the things? Things can be water. Things can be any ion or electrolyte. When I say electrolyte, that means a chemical which is having a positive or negative charge. Sorry. Plus or minus, like a battery. In a battery, we have got plus charges and minus. It is written here minus, and here written is plus cell. So same thing for chemicals like sodium. If it is represented properly, it is +1, or chloride minus. So these minus and plus means they are electrically charged. They have some electrical energy. So that's why they are called as electrolyte. Electrolyte. So when I say the movement of electrolyte, that means anything which is having a plus or minus sign over it. Okay. So transport across the cell membrane means the movement of ion or electrolyte or water from or to this. Suppose this is a cell. This is inside. This is outside. Okay. So anything can move in or go out. Sorry. So that movement is known as, wait a second, slide is open. Here is the slideshow. Okay. So anything can move in or go out. This is touching the slideshow. Okay. I will do it here. Can go out. This is known as transport across the cell membrane. Transport means tahmil, right? Am I right? Tahmil, movement. In Arabic, it is like this.
In Arabic, it's naqal, ya doctor. Naqal.
Naqal, sorry. Al-Naqal, yes. Naqal Jamai. You know Naqal Jamai, the bus which carry you from one city to another city. So transport means Naqal. Okay. So movement of cell, movement of ions or chemicals from or in or out of the cell is called as the transport across the cell membrane. Now, these the process is having special characteristics. Some are using energy, like in the form of ATP, to get in or out. Some are not using. So that's why they are called as those who are using the energy. The process which is using the energy is called as the active transport. The one without energy is called as a passive transport. Passive, without any energy. Okay, let me come to the point. So in this lecture, we described about what is the meaning of permeability, how the border, this is the cell border, suppose, why it will allow some and why it will not allow some. So this is the permeability. Permeability is permission, just like permitting someone to get inside the cell or going out of the cell. This is called as permeability, and it depends upon various factors. Various factors will decide whether the things will move in or out. These factors are very, very important. Now, we will talk about the different types of transport. One is named as diffusion. Second one is known as facilitated diffusion. Third one is known as secondary active transport. Fourth one is known as primary active transport. So in total, we will discuss the four different transport mechanism. Okay, in that we will describe each one in detail, define diffusion and the factors which is affecting the diffusion, or osmosis. What is meant by osmosis and what are the factors, and what is meant by the osmolarity and the osmotic pressure. This we will discuss. And then significance of this diffusion, significance of the movement of any ion or electrolyte across the cell membrane. What will happen because of their diffusion? If someone is moving in, what will happen? Someone is moving out, what will happen? So significance. So to understand the process of transport, we must know from where they are going in or out. So from where they are going in or out, what is the place? Through which place the ions or chemicals or electrolyte moving in or out? What is that place known as? You should not sleep. Now sleep is over. We are revising now. What is the place through membrane? Which membrane?
Cell membrane.
Yes, cell membrane. This is a cell and this is a membrane, the boundary. Okay. So this membrane. So to know the process, we have to know the place first. What is cell membrane? What is this cell membrane? How it is made up of? So cell membrane is, why it is happening like this? So cell membrane, why it is, we have to know. So cell membrane is not a simple, just like a boundary. It has got some chemical characteristics. What are these chemical characteristics? It is, first of all, it is made up of lipid. This cell membrane is made up of lipid. Lipid means fat, right? So it is made up of lipid or fat. It is not a single layer. It is having two layers. The membrane is not single layer. It is having two layers. That's why it is known as bilayer. Bi means two. Bi, bi. Bi means two. Sorry. PWO2. Bi. So it is a two layer. What are these two layers? One is inner layer and second one is outer layer. Two layers are there for this membrane. This is called as a lipid bilayer. And these two layers having, again, a molecule is for making these two layers. What is this molecule? Molecule is phospholipid. This molecule is phospholipid. So phospholipid molecules are making all these phospholipid molecules join together to form a layer, and these T layers becomes 2. Then that's why it is called as a lipid bilayer. Now to know, we have to know this molecule. This molecule is a phospholipid. It has got a polar head, polar head, and a body or tail, you can say, tail. Non-polar. This is non-polar. Now, what is mean by polar? Polar means something which is having a charge, plus or minus. Non-polar means it is not having any charge. Okay. So these two layers, these two molecules are arranged like this, so that the polar molecules are on two sides and non-polar molecules are in between. Non-polar molecule, these are non-polar. These are polar heads. This is hydrophilic. Hydro means water. Philic means loving. So they love water. So they can mix with water here. They can mix with water here. So they are hydrophilic, can mix easily with water. Non-polar, these tail portions are non-polars, and they are called as hydro, means water, and phobic means they hate. They don't love. So that's why whenever water comes near to them, whenever water comes, they will be repelled from the water. They will not come near to the water. These tail molecules. Okay, they are not attracting the water. They are repelling the water. This is the description of lipid bilayer. Why it is remaining here. So this is the detailed analysis or detailed picture of the phospholipid molecule. It has got a head which is negatively charged or polar, hydrophilic, and the tail portion is non-charged, having no positive or no negative. There is no charge, and it is hydrophobic. It hates water or repel water. Okay, so this is how the electron microscopy. This, if you see any cell under the microscope, and the microscope, if it is very powerful, which is known as the electron microscope. Electron microscope is very, very powerful. Even you can see the inside of the cell. Even you can see the inside of the cell. So this is the electron microscopic picture or diagram, you can say. It is not the picture, it is a diagram showing you that this is the inside of the cell and this is outside of the cell. That's why it is known as extracellular fluid, and here it is written as intracellular fluid. And in between them is this is the portion which is called as the lipid bilayer. Now in the lipid bilayer, you will see the molecules are arranged in two layers, plus there are protein molecules, embedded, just like our doors in the walls. Have you seen the doors? These are the doors or windows in our house. In the wall we have windows and we have got doors, something to go in and out. These are nothing but these protein molecules. Plus there are some protein molecules which is responsible for attaching the enzyme or any chemicals, and some are just like a opening, which are called as channels. Some are called as leak channels. We will not go in detail. Some are called as carrier protein. Basically, their function is to pass the thing. Suppose this is the area. So this is from inside and this is from outside. So this area, they will allow the movement. So these are the protein channels or leaky channels or gated channels, one and the same thing. Their function is to transport the things like water, like different chemicals, sodium, potassium, phosphate, chloride, magnesium, calcium, all these things which are there across the cell membrane can move in or out through a specific. A specific means not all the things can pass easily. This is not a general route. Some is only for VIPs, some is for only general public, some is for special person. So there are specific areas, a specific protein, which is allowing, only one is allowing sodium, another one is allowing potassium, another one is allowing chloride, something like that. So there are specific channels, okay? So I'm going in detail. Based on this specificity, because all of the things cannot pass through one area. Based on this, the membrane is known as selectively permeable. Selectively permeable. That means the permission is to move in or out is decided by the membrane. Decided by the membrane. They may allow sodium to go in. They may not allow the sodium to go in. This is based on their criteria. Just like if you have a ticket, you can go inside the hall. Some hall, suppose you are going to the to see a movie and you are moving into the movie theater. Not every person can go inside. Only those who are having ticket can go inside. So this is the permeability based on the special characteristics. So that's why the cell membrane is known as selectively permeable membrane. What is the meaning of selectively permeable? It will allow some molecules, few, specific, maybe sodium, maybe potassium, maybe calcium, or maybe sodium and potassium, something like that. But it will not allow, let's say, glucose. They will not allow glucose, or they may not allow some proteins. So this is their authority. They may allow, they may not allow. That's why it is called as selectively permeable membrane. What is the meaning of selectively permeable membrane? They will select, the membrane will select which ion can move in, which ion cannot move in. This is the meaning of selectively permeable membrane. The structure helps it to be selective. That's why the structure is such that it has got channels, it has got proteins, it has got gates. They will decide whether to keep them coming inside or going outside. So again, here it is showing that it is a selectively permeable membrane. That means it allows some particles and it will not allow other particles based on the criteria. What are the things which can pass? Now, who are these privileged persons who can go in and out without any card or ticket? Who are these? Those who are lipid soluble, because we know this membrane, which is selectively permeable, is made up of lipid. So lipid soluble substance can easily pass. They can easily go in and out. These are nothing but respiratory gases, O2, CO2, fatty acids. They can easily go out. Whenever they like, they can go. Whenever they don't want, they will not go. So it is not allowed for, not possible to stop them. So these are the sodium, CO2 and CO2 can easily pass without any permission. They don't require. Plus some ions which are very, very tiny. It is 0.8 nanometer. If these are 0.8 nanometer particles are there, they can pass easily. They can pass easily in and out. So these are the two criteria where the lipid bilayer will not stop them moving in or out. Those which are fat soluble and those which are less than 0.8 nanometer. Now coming to the two types of movement. When I say this is the layer, this is the layer which is allowing the things to move in and out. Now this process of moving in and out can be classified into two types. One is passive transport. Second one is active transport. The movement from here to here can be active or can be passive. Why we call it as active and why we call it as passive? We will call it as active when it requires some energy. Energy in the body is produced in the form of ATPs, adenosine triphosphate. So thus, if the movement requires energy, it is an active process. When the movement does not require energy, it is called as a passive process. Now, this is the example given here. Here is the jabal, or a mountain. So from the mountain coming or coming down does not require energy. It is just push. If you push someone, it will go fall down and then come down till the base. Or maybe you can think about the slide in the park. Have you gone to the slide sometimes? Here you go up and you can, somebody pushes from here behind and you come down without any energy. But for going up, you require energy. If you want to go up, you require energy, right? So the one which is coming down is without energy, does not require energy. So from which, if you measure the height, this is suppose 5 meters, suppose 5 meters, very small. 5 meters, and the height is 5 meters here, and here it is 0. So from 5 to 0, it is from high to low. But from 0 to 5, it is from low to high. Okay. So from higher to lower, it does not require energy. Doesn't require energy. Sorry. Doesn't require energy. This is called as passive process. From, let's say it is 100 meters, 100 meter height. And this is 0 meter at the base. So from 100 to 0, it does not require energy. But from 0 to 100, it requires energy from lower to higher side. You get my point?
Yes.
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 So the process from higher side to lower side, which is not requiring energy, is called as passive process. The process which is from lower side to higher side or high concentration, if you just change the side or height to concentration, this is low concentration, this is high concentration. Or so it requires energy. It requires energy in the form of ATP. It requires energy in the form of ATP. Also, it requires pumps. These pumps, which will throw the sodium in or out. These are called as pump. Just like water pump in your house, which is throwing water from the khazan to the top area, to the top of the house, and then water will come into the pipes. Okay, this is the pump. So two processes are there. One is called as passive process, which does not require energy, and active process which require energy. The process which does not require energy, it is always from higher to lower concentration. If two concentrations are made across the cell membrane, let's say this is a cell membrane, and inside it is, let's say 100, and outside it is 0. So it is always from 100 to 0, higher to lower. This is passive process, which is not requiring energy. No ATPs are required, no. Okay. Whereas other process, again, I will put 100 inside and 0 outside. So from 0 lower to higher side, if it is allowing through the pumps and it is requiring energy, it is called as an active process. This is an active process. This one is passive process. What are the example? Example of passive processes are diffusion. Another type of diffusion is facilitated diffusion. And third one is osmosis. Diffusion, in Arabic, it is known as intishar. In Arabic, it is known as intishar, diffusion. Facilitation means with some help. Facilitation. I will help you to pass the exam. So I will facilitate you. I will facilitate you to understand the information. So I will help you. This is the meaning. So facilitate diffusion, the diffusion which requires help from some other. This is called as facilitated diffusion. I will show you the example, correct. Then osmosis means it is simple. Diffusion of water. Diffusion of water is known as osmosis. Okay. Okay, let us go to the next slide. So passive transport does not require any energy. Molecules are moving randomly, any direction, everywhere. This is called as random motion. Because of this random motion, they can go from very high concentration here. Suppose this is a room, and here we spray the air freshener. If you just spray the air freshener here, very high concentration, it will move to the whole the room. The smell will move to every part of the room after maybe few seconds or a minute. This is high concentration here, and here there is no. So that's why it will move from higher to lower side. This is called as diffusion, intishar. So from their higher concentration to lower concentration, this is called as passive transport, as the name is diffusion. So diffusion is moving from very high concentration to low concentration. Facilitated diffusion, the diffusion with the help of transport protein, with the help of some other protein. This is called as facilitated diffusion. There is intishar, but it requires protein molecule to help them to go from higher to lower side. Whereas osmosis means diffusion of water. When there is a tank and it is separated by a membrane, and here it is full, and here is nothing, and this membrane is permeable. So water will move. It will not stop. Till what time? Till both the side will become equal. Till both the side will become equal. So it is becoming equal on both sides. This is called as osmosis. Movement of water or diffusion of water through a semi-permeable membrane is called as osmosis. Okay, here it is. In English, it is known as spreading out. So the molecules are moving in a random motion all the time. Whenever it is released in an area where there is low concentration, they will move out. They will be spreading out. There should be concentration gradient. If the containers are having different concentration, suppose here it is very few and here are many. Here are many. This is B and this is A. So from where to where they will go in diffusion?
High to low.
Which container? Here the A and B are these two containers, two areas. So they will move from
B to
From
A.
B to A.
yes, from higher to lower
B to A.
concentration. Yeah, B to A. This is called as the simple diffusion. If the membrane is permeable, the first condition should be the membrane should be permeable. That means it will allow permeable membrane is there or semi-permeable membrane is there. Then it will move from higher to lower concentration. This is called as simple diffusion. Simple diffusion. Here is the example. Okay, in the exam, the question may be out of these criterias, which is the criteria fulfilled by diffusion, or diffusion will occur when? Maybe number one is there should be a specific pump should be there, or there should be low concentration on the other side, or there should be thicker membrane, something like that. membrane is thick, or maybe there should be energy. So what will be the answer?
Low
Doctor, can you
concentration.
repeat the question?
Diffusion of a substance will occur only when there is a pump, or the other side is low concentration, or the membrane should be thick, or there should be energy, ATP. This is regarding diffusion, huh? Yeah, there should be low concentration on the other side, then only it will happen. If both the sides are equal, suppose 10 molecules here and 10 molecules here, will the diffusion will occur?
Both direction.
Either both direction, or there should be no, you can say no net diffusion. No net diffusion. Net means there should not be, like, it will not become 10 will not become 20. Every time it will become 10 only, but some molecules are moving. Some molecules are moving. Same number. One is moving here, so the second one is moving on the other side. So no net diffusion. At the end, you will find 10 on 10 both equal. Okay. This is why here saying diffusion will continue until the molecules are evenly spaced or equilibrium is reached. Suppose there is a container and it is having two membrane separated by a semi-permeable membrane, and here are the 15 molecules, and here are, let's say, suppose how many, maybe, or maybe I will give even number. Suppose here is 100 molecules and here is 20 molecules. So movement will occur from higher to lower side, from 100 to 20, till what time? Till both sides will become 60 and 60. This is called as equilibrium, as because here 100 plus 20 is equal to 120. So total 120 will be distributed in 2. So both sides will become equally concentrated. This is called as equilibrium is attached, equal. Okay. Till that time there is a movement. After that, you can say there is no net movement. No net movement means does not mean there is no movement. There will be movement, but equal. One molecule is going out of the cell, second molecule is going into the cell. Okay. Here is the example: higher concentration, dark color, and lower concentration. This is high, this is low. So the arrow will be from higher to lower side till both sides will become equal. So there will be no net diffusion, although there is movement here also, but equal in amount, equal in amount. What is the example of diffusion in our body? In our body, diffusion, best example is diffusion of gases. Diffusion of gases, carbon dioxide and O2 and CO2. So if you remember, the air enter into the body through nostrils, and it reaches to the lungs, right? It reaches to the lungs. So O2, which is how much is the concentration in the atmosphere? 100% oxygen is present in the atmosphere. At the tissue level, the blood is there, or this is a cell. So at the tissue level, because the oxygen is utilized, oxygen is continuously utilized by the cell, the oxygen concentration becomes around 60 millimeter of mercury. This is inside the cell, you can say. Here is 100 in the atmosphere, and here in the tissue or in the cell it is 60 millimeter, because oxygen is continuously utilized by the cells. So when you inhale, then oxygen will enter into the lungs. In the lungs are made up of alveoli. These are the cells in the packets in the alveoli. You remember that how the lung is Lung is made up of these small areas, pockets. These are known as alveoli, like a bunch of grapes. Like a bunch of grapes. And along with this, there is a blood vessel. There is a blood capillary. Blood vessel. So O2 will enter into this alveoli. O2 will enter into the alveoli when you inhale. Then it will cross this membrane. So I will draw a bigger picture here. This is one alveoli, and here is the blood vessels. Or capillary. The best is capillary, the real one. So this is alveoli. Alveoli receiving the oxygen, which is 100 millimeter of mercury pressure. Now it has to travel from the air sac or air pocket to the blood, because in the blood you have got RBCs. These are the RBCs. If you see them from the side, they will look like a disc shape. These are RBCs. So whenever oxygen enter into the alveoli, it has to cross this membrane. What is this called as? This is called as respiratory membrane. Respiratory membrane. Very thin. It is just like very thin membrane. It is just like this thin membrane. Here is the alveoli and here is the blood vessel. So very thin area is there normally. So oxygen will be, which is higher here, and in the blood maybe it is 60 millimeter of mercury, because it is coming from the cell. So it will move from higher to lower concentration, from 100 to 60, and crossing through the respiratory membrane. Respiratory membrane. In some conditions, this is the process of diffusion. Huh? In some condition, this membrane becomes thick, like in case of pneumonia. You know the condition pneumonia?
Yes.
Yes.
What happens in pneumonia? The doctor usually says chest infection, okay? It is chest infection. Or in Arabic, I think the name is iltihab as-sadr or tanaffus. Something like this. This is inflammation. Iltihab means inflammation. Inflammation in the lungs. So because of this inflammation, this respiratory membrane, which is normally in this size, it will become edematous. You know edema? Do you know edema?
Yes.
Edema is accumulation of fluid. Yeah, accumulation of fluid. So fluid get accumulated here because of pneumonia. Because of pneumonia. So this membrane, which is supposed to be, let's say 0.1 millimeter, it becomes 10 millimeter. It becomes 10 times higher, or maybe increase in thickness. So it will make difficult for oxygen to go from one area to other area. It will be slow. It is going, but will become slow. Because it goes slow, in the blood also, it will be decrease, not becoming 100. It is maybe remaining maybe 70, 80% or 80 millimeter of mercury instead of 100, because of slow diffusion of the gases. So edema causes thickness of the membrane, and if it is thick, it will be slow. So the example of diffusion is diffusion of oxygen from atmosphere to the cell through the blood, and diffusion. Another example is diffusing out of carbon dioxide. Carbon dioxide is produced inside the cell. So because of the chemical reaction, most of the carbon dioxide is produced and it has to go out of the body. So it will move from the cell, enter into the capillary. This capillary will bring into the lungs, and from the lungs it will go out during expiration. CO2 will be out. This is the cycle. Okay. So if the respiratory membrane becomes thick, both the process, oxygen moving into the blood will be slow, and carbon dioxide moving out of the blood is also becoming slow. And that's why there will be decreased partial pressure of oxygen in the blood. In the blood, the oxygen will be low, and the person will be advised to have oxygen all the time. He will be fed with the oxygen cylinder mask through the mask. Okay, now this is the actual. These are the fact. Okay, please tell me the question.
Is there a picture will coming on the exam?
Yes,
Yeah.
pictures will be coming in the exam.
Okay, can you give us example like in each slide?
Yeah, sure.
Thank you.
So what are the things which will decide the diffusion should be faster or slower? What are the things? The things are difference of concentration. Difference of concentration. What is mean by difference of concentration? Suppose this is a cell, this is in, and this is out. Concentration here is 100, here is 10. What is the difference? 100 minus 10 is equal to 90. This 90 is nothing but concentration gradient or difference. Difference means, gradient means the difference of concentration across the cell membrane. Inside and outside, how much is the concentration difference? So you have just the higher value minus lower value. Suppose inside is 10 and outside is 9. So the difference is 1. 1 maybe pressure or volume or amount. So this is 10 minus 9. This is the concentration gradient. So this will decide the rate of diffusion will be faster or slower. Then permeability, how permeable the cell membrane, how much it is freely allowing them to pass. Surface area of the membrane. Suppose this is the membrane and it is allowing the things to pass. If this membrane will become like this. See here, this is maybe only 1 millimeter in square meter, suppose, and it becomes 10 square meters. So this is more. So surface area increases, the rate of diffusion will also increase. Molecular weight, weight of the molecule. If the molecule is, let's say, very small or very tiny, it can easily pass. If it becomes thick, big, high, or heavier, then it will be slower, very slow move. Then thickness, as I told you, if it is like thin, it will be easily passing. If it becomes thick, it will be slow. So to add them together in one formula, the net rate of diffusion for any substance, let's say oxygen, let's say carbon dioxide, let's say sodium, or we say net rate diffusion is represented by Q, is equal to concentration gradient multiplied by permeability multiplied by surface area divided by molecular weight or the thickness of the membrane. What this formula indicates? This formula indicates that rate of diffusion is directly proportional to concentration gradient. Rate of diffusion is directly proportional to the permeability. Rate of diffusion is directly proportional to the area. And rate of diffusion is indirectly proportional to molecular weight. Rate of diffusion is indirectly proportional to the thickness of the membrane. Okay, now what is mean by direct proportional? Direct, and this is indirect. You can see this is indirect. Direct proportional means whenever concentration gradient increases, there will be increase in rate of diffusion. This is direct. Whenever the permeability increases, there will be increase in rate of diffusion. Whenever surface area increases, there will be increase in diffusion rate. What is indirect means? Indirect means whenever molecular weight increases, the rate of diffusion will be decreased. opposite. Indirect means opposite. When one increases, other will decrease. Whenever the thickness of the membrane increases, increased thickness, rate of diffusion will what will happen? Will increase or decrease?
Decrease.
When it decrease, when it becomes thick, this much size, it will become slow to go out, like oxygen to move into the blood. Here is the RBC. This is the RBC. So it will be slower to enter into the RBC or maybe increasing in the blood. Okay. So thickness will cause decreased diffusion. Increased thickness will cause decreased diffusion. This is what occurring in pneumonia. This is what occurring in pneumonia or any lung inflammation. Any lung inflammation, there will be thickness of the respiratory membrane, which is decreasing the concentration of oxygen in the blood. Okay. Whenever anything pass from one side to another side, this is suppose inside and this is outside. Anything pass from one side to another side, either it will change the chemical composition or it will change the, suppose these are charges, plus minus here and there. If they are moving in, they will change the electrical property or electrical potential, electrical charges. If suppose chloride is moving from inside to outside, concentration of chloride will be becoming higher on the outside. If suppose sodium is moving from out to in, the concentration of sodium will become higher inside. So either increase in the chemical composition will change or the electrical composition will change. This is known as, this will create a difference. That's why it is known as a chemical gradient will be produced, chemical difference or gradient, or electrical gradient will be produced. Electrical gradient. Because of unequal movement of the ions across the cell membrane. And this is why whenever you see the cell, it is positively charged from outside and negatively charged from inside. If you put a galvanometer inside, this will show negative sign. Okay. If you put galvanometer outside here and just check how is the difference, it is positive. So positivity outside and negativity inside because of the diffusion of the electrolytes, electrically charged particle. So remember three words. Because of the movement, either the chemical will change, so it will create chemical gradient. Either the electrical charges will become change from inside to outside, so it will create an electrical gradient difference, or both of them. If electrical change is there and chemical change is there, it is known as electrochemical gradient will be produced. Means the cell, there will be positivity, plus there are more sodium, whereas there are more potassium inside. This is how it will be created. So chemical change plus number of charges. So both of them together is known as electrochemical change or electrochemical gradient is produced because of the unequal or different rate of diffusion of different substance. So up till now we have we discussed the diffusion only. Now what is mean by facilitated diffusion? Same thing, except the diffusion is taking place with the help of some ion channels. So here is the specific doors are there through which the molecules will be moving, and again it is from higher side to lower side, higher concentration to lower concentration, but with the help of a gate or a protein or a channel. This is called as facilitated diffusion. Diffusion with the help of any specific protein, Understood?
Yes.
It is from higher to lower. No, it will not occur from lower to higher. It is from higher side to lower side, but it requires a specific protein channel. This is called as facilitated diffusion. Here is an example of facilitated diffusion of sodium ions, So sodium ions which are higher outside and lower inside, but because of the sodium channels, whenever they will bind, they will change the shape and they will become different. Just like before they are like this shape. So when the ion binds here, it will change its shape and will move the ion inside. This is the example of sodium transport across the cell membrane with a sodium channel. It requires sodium. Sorry. Yes.
For example, this picture are gonna come on the exam.
Yes. Which type of transport mechanism is shown in the picture? Maybe one picture. Let's say I will select this picture. Which type of transport mechanism? Now you can see higher concentration outside, lower concentration inside, and the arrow is showing the movement is occurring inside and it is occurring through a specific protein. So first is higher to lower is diffusion. Okay. Now
this one is
specific
right?
protein is there. That's why it is facilitated diffusion.
So doctor, the answer will be facilitated diffusion for this
Yes,
picture.
let's say I will give you diffusion, facilitated diffusion, active transport, and some osmosis, let's say. So it is diffusion, but with the help of protein, that's why it is facilitated. Second, B. Like this picture will come.
What about the other pictures?
No, this whole process cannot be given in the picture.
Okay.
I have to make the question with the picture. So diffusion through a specific protein channel from higher side to lower side is called as facilitated diffusion. And these channels are the part of the lipid bilayer. These channels or these proteins are part of the lipid bilayer and they can open and close with the help of gates. Just like a gate in our house. This is a gate, suppose this is a gate. So they will be, it is opening and closing with the help of gates. The help of gates. This is the protein channel.
Doctor,
Hmm.
what does IMP stand for?
Where is IMP?
These channels are distinguished by two.
Where is it? In this slide?
Yes.
Important. Two important characteristics. Sorry. Important characteristic. These channels are distinguished by two important characteristics. One is selectively permeable, not allowing anyone to go in. Only specific, like if it is made for sodium, sodium will go. If it is made for potassium, potassium will go. And open and close by gates. These channels are specific.
So this is the only important in this slide.
Two characteristics are there for the ion channels, integral channels or for facilitated diffusion. Two important characteristics are there.
Doctor, how will comes the exam for this slide? How will it come?
No, not for slide. Exam cannot come by slide. Exam
know.
will come by concept. I will give you I will ask you, maybe the membrane has got the characteristic when it is allowing a specific protein, we call it as not allowing everyone, but only allowing the specific people. What do you call?
Selectively permeable.
Yeah, selectively permeable. Selective. Good. Or maybe related to selective permeable, maybe other options will be there. Impermeable or something different, weird name is there, but you have to figure it out.
Okay, thank you.
Doctor,
So yeah,
why it mentioned there, but it is by simple division, while simple division doesn't require ion channel or any channel.
where it is written? Okay, here. Ion channels are the integral part, integral protein, tubular pathway, all the way from the extracellular to the intracellular fluids. Substance can move by simple diffusion. Meaning of simple diffusion means always from higher to lower concentration. Okay, this is the meaning.
Okay, so it's just the movement.
Yeah, this is the movement. Movement is,
Okay.
diffusion is movement from higher to lower side. It is occurring through a channel. It is occurring through a channel. Okay. Here is the example of these gates. The gates are there. These are the protein. Again, this is a part which is called as gate. When the gate is closed, it is on the outside for sodium. Similarly, for potassium, the gate is inside. This is the flap which is closing and opening. So it is present inside for potassium. Osmosis is nothing but diffusion of water. If you have got water separated in two parts of a tank, which is semi-permeable membrane. This is the membrane, semi-permeable. On one side, this much water. On the other side, this much water. So it will be from higher to lower till both sides will become equal, till both sides will become equally filled. But this is only for water. That's why it is called as osmosis. Osmosis is nothing but movement of water from its higher side to the lower side, lower concentration of water. Here is the water molecules separated. Now, what is happening here is the low concentration of water. Here is the high concentration of water. No, these are not the molecules of water. These are some other molecules. Let's say sugar molecule. This is a water with sugar, and this is pure water. So pure water without any sugar has got more concentration. Here is the more concentration. So after some time, the water will move from higher to lower side. So it will become this much, and here it will become smaller one. You got my point here? For water, you have to think about the tea. Let's say these are the 2 cups of the teas, all having 10 ml. Capacity is 10 ml. Okay. Now this tea is having water plus sugar. This is also having water plus sugar. Okay. Here in 10 ml, we put 2 spoon sugar. Here we put half a spoon sugar, just half a spoon sugar. So by concentration, here it is highly concentrated, right? Because two spoons of sugars are there, very sweet. Here it is little sweet. So it is low concentration of the sugar, but high concentration of water. Water is more, sugar is less. Water is less, sugar is more. That's why the water will move from, this is cup A and cup B. Suppose there is a membrane in between. So from where to where the osmosis will take place or diffusion of water will take place? Tell me.
From A to B.
B to A.
Why A to B and why B to A?
From high concentrations of water to low concentration of water.
So that's why it is from here to here. From A to B. Here we call it as diluted, right? This is diluted because less sugar is there. Here it is concentrated, means more sugar is there, but less water. Water is less and here water is more. So that's why it is from more to high, more to low. More water to low water. This is called as osmosis. And to prevent this osmosis, suppose you don't want to mix them. We don't want the water should move from higher to lower side. If you apply some pressure, if you apply by force, you are not allowing them to move. This pressure is known as osmotic pressure. Osmotic pressure means the pressure which is applied to prevent osmosis, is known as osmotic pressure. The pressure which is applied to prevent osmosis is known as osmotic pressure. You get my point?
Yes.
Okay. So osmosis means diffusion of water through a selectively permeable membrane. Water is so small, there is so much of it is of the cell can't control its movement through the cell membrane. So always there is a movement of water is taking place. Now some terminologies. Osmoles are those particles which are osmotically active. Osmotically active particles, if they are present in a solution, we call it as osmoles, number of osmoles. Simply you remember that it is a concentration. It is a concentration. Okay. Suppose this is a cup. And here is the water plus sugar. Water plus sugar is there. So sugar are osmotically active particle. And the concentration of osmotically active particle in 1 liter per liter is called as osmolarity. Osmolarity is the osmotically active particle in a solution per liter is called as osmolarity. Another term, osmolality, L instead of R, L is there. Osmolality is the number of osmoles, osmotically active particles per kilogram instead of per liter. This is just the difference. Per kilogram, it is called as osmolarity. Sorry. Normally, cells are there and there is extracellular fluid. The fluid is present inside the cell. We call it as intracellular fluid, right? This one is a cell. What is cell? Cell is qalia. So water is present inside also. Water is present outside also. The solutes are present inside also. Solutes are present outside also. So there is some concentration. There is some osmolarity. There is concentration inside of the fluid and outside of the cell's fluid. So what is that concentration? That concentration is around 300 milliosmol per liter. This is the concentration. Outside also 300 milliosmol per liter. Normally, this is normal. But it's not exact 300. It is ranging between 275 to 295. But approximately for the learning purpose, for describing the formulas or calculation or understanding the osmolarity, we say it is around 300 osmoles. So if you say RBC, the osmolarity within the RBC is 300 osmol. If you take the plasma, the osmolarity of the plasma will be 300 milliosmol per liter. This is the osmolarity. You should know that this is normal. This is normal when everything is normal. Everything is normal in the body. The osmolarity is around 300. Osmolarity will change if you lose water or if you will gain water. Osmolarity will change. Suppose you add more water to the cup in 5 milligram of sugar. Suppose sugar is there, only 1 spoon sugar is there, and you added maybe two glasses of water to one spoon of sugar. Will it be of same taste? No, it will becomes more diluted. Or if the if there is a water and you just remove the water and keep 1 spoon of sugar, it will become more sweeter if you lose water. Okay, because it is becoming more concentrated. So osmolarity will change if you gain water or you lose water. In the body, from where the water goes inside and outside? In our body, how the water is enter into the body and how the water move out of the body. Tell me the conditions or the pathway or the areas. How the water concentration in our
drinking and out of the body by sweating, for example.
Yes, when you drink, the water is moving into the body. When you are urinating, passing the urine, then water is moving out, or maybe passing the stool, or maybe sweat, the water is moving out. So these are the areas. So if you drink lot of water, suppose you drink maybe 2 liters of water, the osmolarity will change to more or less. Osmolarity will become more or less when you drink lot of water. Simple question. What will
More?
osmolarity will become more or less when you drink more water?
Less.
Less means what? What will be the number?
It will be diluted.
Yeah, it will be diluted. What will be the number? The number, magic number. Less than 300. Very good. If you add water to the body or you drink more water or water is not going out of the body, then water will be retained inside and it will become, the osmolarity will become less than 300. Not 300, may go to 200 or maybe 250, something like that. Suppose now in Ramadan, you are not drinking water. So maybe at the time, just before the iftar, just before Maghrib prayer, what will be your osmolarity? Will it be 300? Will it be 250 or will it be 350? What will be the answer?
More than 300.
More than 300. Yes. If you have decreased amount of water in the body, the osmolarity will increase. Good. So type of solution. Solution means some water plus some solutes. Okay. We call it a solution. So types of solution are hypotonic solution. Hypo means low. Whenever term hypo means low or below is coming, low. Tone is concentration. Low concentration. So osmolarity is less. Osmolarity is less. This is called as a hypotonic solution. In this hypotonic solution, 10% of salt. Water will be more outside and less inside. So that's why water will move into the cell and the cell will become bigger, swollen. If you add hypotonic saline, then less than 300, then the cell will receive water. And cells will becomes big, so big that it will burst. It will burst. Water will come out. This is called as cytolysis. Cyto is cell, lysis is breakdown. So cell will break down in hypotonic solution. Suppose opposite to condition, hyper. Whenever we say hyper, hyper means more, above, big, hyper. Tone is concentration, more concentration. That means more than 300, more than 300 milliosmoles. Okay. If you put a cell into this much amount of concentration, the water which is less outside and more inside, the water will leave the cell and cells will shrink. Cells will shrink. And this is known as plasmolysis. The condition is known as plasmolysis. Plasma will receive water. Third one. ISO. What is the meaning of ISO? ISO is same. ISO, meaning of ISO is same. Tone means concentration. Same concentration as inside or outside. Here it is shown 10% solution and inside is also 10% solution. So both are same. So in our body, 300 is the osmolarity. So if you give 300 osmolar solution, there will be no problem. What will happen? There will be no problem. The cells will remain of a normal size, or the dynamic equilibrium will be there. Dynamic means it does not mean that the water is not moving. Water is moving, dynamic, but it is moving in the same quantity. That's why it will remain in the equal sign, equilibrium. Same here, 300, same outside 300. But there is some movement is taking place. This is called as dynamic equilibrium. Every time it is remaining only 300. So now, if you put the cell in a normal or isotonic saline 300 milliosmol, the cells will remain normal, no loss or no gain of water. If you put it in a hypotonic saline 200 milliosmol, water will move in, cells will swell, and they may burst. Cytolysis may occur. If you put the solution of a higher concentration, that is 400 osmolarity, the water will be lost from the RBCs and RBCs will be shrink. RBCs will shrink. This is an example which shows that if you have to identify what is the solution in B, which type of solution it is?
Isotonic.
ISO. Why? Why isotonic?
Because it's equal.
Because the cell did not burst here, not becomes small, not becomes big. It remains the same size. That means same amount of water is moving in, same amount of water is moving out. Okay, what is the solution in A?
A
Hypotonic.
Hypotonic solution.
No, hypertonic.
Hypertonic. Because outside is more concentration, so water will move out. Water is moving out, so cells will become shrink. And what about this? C. Cells are becoming
Hypotonic.
Yeah, here it
Hypotonic.
is hypotonic solution less than 300. Less than 300, maybe 250, 200 or 150 something. That's why water is moving into the cell and the cells becomes burst. Okay. So you can identify from the picture also which type of solution is here. Okay. So from this lecture, what are the important points you think? What are the important points? How will you define, or how will you say that if I want to say in few lines? Transport across the cell membrane. Can anyone just summarize 1, 2, 3, 4 points?
Difference between passive and active diffusion.
Okay. Yes, very good.
Also difference between isotonic and hypotonic.
Yes. Okay.
Selectively permeable.
Permeable, yes. So if I have to describe the chapter, this chapter includes method of transport across the cell membrane. First, two types of transport mechanism. One is active transport, second one is passive transport. What is that? Why we call it as active? Why we call it as passive? Basic difference is in active transport, we require energy. We require ATPs. Also, the movement is taking place from lower to higher concentration. Active means you have to go from the baseline to the top of the hill. You require energy, and it is active transport, and it will be from lower to higher side, 0 to 10 feet, 0 to 100 feet, something like that, or 0 molecule to 0 concentration to 10 concentration, something like that. So from lower to higher side, this is active. Passive means does not require energy, don't require energy, just like sliding. So slide is from higher to lower side. On one side it is 20, another side is 2. So from 20 to 2, the movement will take place. Okay, this is the basic difference between active and passive transport. In passive transport, we discussed 3 mechanisms. One is diffusion, simple diffusion. Second one is facilitated diffusion. Diffusion is first type diffusion is we call it as simple diffusion. Second type we call it as diffusion also, but with facilitation. It requires some protein pump. Third one is osmosis. So three mechanisms we have learned. Diffusion without requiring any specific protein, just from higher to lower side. Facilitated diffusion, also like a diffusion from higher to lower side, but requires a specific channel or protein and does not require energy. Then osmosis. Osmosis also is a type of diffusion, but not of other chemicals, but it is of water. Movement of water from higher side of concentration to the lower side concentration. Okay, this is called as osmosis. Any pressure which prevent osmosis is known as osmotic pressure. Now, diffusion also depend upon certain conditions. What are these conditions or factors? One is concentration difference. Second one is the surface area available. Then third one is, what is the third one? Concentration difference.
Permeable membrane.
Permeability.
Membrane.
Yes, permeability, concentration difference, and the surface area. Then the fourth condition is thickness of the membrane, and fifth condition is molecular weight. These are the 5 factors which is affecting the rate of diffusion, how faster the diffusion will be. So in first three factors, that is the permeability, the concentration difference, and the surface area. Anything increase will increase the rate of diffusion. Out of any of these 3, permeability, concentration difference, or the surface area, any of them increases, it will increase the rate of diffusion. Opposite to that, the molecular weight and thickness of the membrane, if any of them increases, diffusion will decrease. This is a specific for these 2 factors. That is the molecular weight, if it increase, or thickness will increase, the process will become slow. Rate of diffusion will become slow. So this is the summary of the previous chapter. Now let
Doctor?
us move. Yes.
Will the picture will come like from the same slides, like our slides?
Yes, from your slides only. Coming to the body fluids, I will go quickly because this is an easy chapter for me. Maybe same is true for you.
Doctor, can you tell us on this chapter the important things?
All are important. Everything is important.
Okay, can you like delete the slide are not
Nothing.
important?
No, all the slides are interrelated. You cannot delete one slide and concentrate on one because this is a story. If you remove one part of the story, you cannot link them together.
Okay, can you give us example how will it comes?
I give you the example how these are the different molecules and how whether it is diffusion will be taking place or osmosis or something like that. So type of transport will be there and condition will be there. If suppose movement is taking place from higher to lower side without any energy, without any protein, which type of transport? Diffusion, osmosis, something like that. So don't think that it will come from exactly this part as a line from the chapter. It is the concept. Physiology is mainly about concept. It is not about structure. If you are reading like anatomy, it is a structure, but physiology is process, mechanism.
I don't know, but I think like I'm confused.
Once, okay, for you, if I suggest, just type on the Google
Yeah.
MCQs for transport across the cell membrane.
Okay.
Very easy way to judge yourself. Maybe in the evening now, to after iftar, you can just type, Google it, that give me 5 MCQs or 5 MCQs on transport across the cell membrane, physiology of transport across the cell membrane. Definitely you will get type of 100 of questions will come. And if you try to solve it, oh, you will understand this type of questions will come.
Okay, thank you.
I can show you now here maybe. Let us say start with I will click. No need to panic. If you understand the thing, definitely it will help you to answer the question. Definitely. Most important is understanding. Don't memorize. You cannot memorize the slides. Sorry, it is taking long time, but in between, if it is open, I will show you. Coming very quickly to the body fluids. The fluid in the body. Al-ma fil jasad.
Doctor,
Hmm.
the second lecture, you didn't put it.
Which lecture? This is
Transport
for.
across the cell membrane, the second one.
Oh, second one. This is very, very important. Okay. Oh, I thought maybe the whole thing is over. Oh, difficult. It is taking too long. It's taking too long for me now. Give me, okay, I will open it here. Maybe MCQs. MCQs for transport across the cell membrane. By the time I will open the other slide, lecture 3, active transport. Oh, it is also important. Huh? I thought only 2 lectures are there with me, and I took almost 1.5 hours explaining you. Sorry, it's taking too long time, but we will try to summarize the things quickly instead of going in detail. Because you did not give me exactly questions. Otherwise, I could have discussed the questions only, not all. So this is lecture 1 only. This is body fluid. Now it's opening. My computer is very slow. Okay. In the transport across the cell membrane, lecture 2, it is mainly about active transport. Active transport. And most of the thing about active transport in the previous lecture. Active transport means it is always from, sorry. It is always from lower to higher side, active transport. It requires carrier molecule. It requires a carrier molecule, and it requires energy, ATPs. So 3 things should be there. Lower to higher, carrier molecule, and ATP. Whenever it is there, it is called as an active transport. So active transport can be of 2 types, primary active transport and secondary active transport. Primary, why it is called as primary active transport? Because primary means on the process, on the site of the transport, energy is utilized. At the site of transport, energy is utilized. This is called as primary active transport. Whereas secondary active transport is transportation is occurring through carrier, energy is used, but energy or ATP is not on the same side. It is coming from some other ways, some other side in the system. Suppose this is a cell, okay, and you have got a primary active transport is happening. Primary means energy is utilized at the same place. So 3 sodium, this is a sodium potassium ATPase pump example, and 2 potassium is coming in. Sodium is low inside and high outside. So from lower to higher, it is active transport. It is requiring pump. That's why it is active transport. Energy is utilized because ATPase enzyme is there, which is breaking down ATP into ADP, and energy is used. That's why it is primary active transport. Because of this sodium moving out, there is another pump is there, which is called as sodium glucose pump on the other side. What will happen because of low sodium inside and high sodium outside now? Sodium will try to move from higher to lower side, but here it requires a pump, which is sodium glucose transporter, SGLT. This is the name of the pump, name of this channel. And it is transporting both the things, sodium plus glucose. So sodium is moving in and glucose is also moving in, but there is no energy utilized here. The energy is utilized here. This is creating a sodium low concentration. That's why it is called as a secondary active transport. Okay. Secondary active transport driven by an ion concentration gradient established by primary active transport. Primary active transport, what it is doing? It is throwing 3 sodium out. So sodium is becoming less inside. This gradient is created by primary active transport, which is making this channel to function to pass sodium from outside to inside, but not alone, but along with the glucose. This is called as secondary active transport. Third is endocytosis and exocytosis. Endocytosis means whenever the cell wants to take a big molecule inside, it will do a process which is called as endocytosis, where the molecule or the packet will bound to the cell membrane and cell membrane will enfold and the thing will be released inside. This is how step number 1, 2, 3, and 4. So this pocket or packet will come inside. This is called as endocytosis. Opposite to that, exocytosis means whenever cell want to release, suppose this is a hormone. If the cell want to release it outside, what will happen in the next step? It will come near to the cell wall, bind with the cell wall, and in the third step, it will open outside the cell wall. And here it will be released. This is called as exocytosis. All of these processes are active transport mechanism. So 3 transport mechanism. One is primary active transport. Example is sodium potassium ATPase pump. Secondary active transport, because of the sodium potassium ATPase pump, the concentration gradient of sodium is changed, and this will allow sodium to move into the cell on the other direction. This is for, and along with it, glucose will also moving in. This is called as secondary active transport. Then third one is vesicular transport, where important vesicle is formed. The cell or the pocket will form, and it will be either taken in or given out. This is called as endocytosis or exocytosis. Here, the primary active transport movement is taking place against the concentration gradient from lower to higher side. That's why it is primary. And it requires energy, and there should be a carrier protein. Carrier protein is there. Okay, here it is the example. Primary active transport. High concentration outside and low inside. In the next step, the energy is utilized at the pump. ATPs are converted into ADP, and there is becoming this pump will become very active now, and the molecule will bind to the active site, and then the conformational change. Before it is like this, Now it will change to like this. So the molecule is thrown out from lower to higher side. And with the help of energy, that's why it is called as a primary active transport. Best example for primary active transport is sodium potassium ATPase pump. Sodium potassium, full name ATPase pump. All of you should make a tasbih of this. Revise so many times. Sodium potassium ATPase pump, sodium potassium ATPase pump, sodium potassium ATPase pump. Why? Because this will be for your lifetime. Every place you will come across this pump, sodium potassium ATPase pump. It is present in every cell and it is continuously active. And what it is doing, it is throwing every time in one cycle, it is throwing sodium from inside to outside. From inside to outside, not one, 3 molecules. 3 sodium is moving out, and every time when 3 sodium goes out, 2 potassium is taken in. Remember by heart, if I ask you, even in your dreams, you should tell me that sodium potassium pump is a primary active transport, and all the time in one cycle, in one go, one circle, it is throwing 3 sodium out, taking 2 potassium inside to create a stability in the cell. If you block this cell, the cell will die. Definitely, cell will die. One cell die or 100 cell die, the person will die. So sodium potassium ATPase pump is a life. You can say it is life. There are some conditions, like if you are doing surgery, suppose I got a injury on my finger, broken, skin is broken or the bone is broken, and the doctor has to fix. I will feel pain, severe pain, right? If somebody try to stitch my skin without any anesthesia, I will feel severe pain. What the doctor will do? Doctor will inject one drug. This is known as anesthetic drug. Anesthesia. This will block this pump for some time. This will block this pump for some time, maybe in the nervous tissue, maybe in the skin tissue. That's why I will not feel any sensation. This is not functioning, or this sensation is, or the impulse of sensation is blocked because of the anesthesia, because of the blockage of this pump. This will lead to no sensation, no sensation is going. So I told you that this is a very important pump, sodium potassium ATPase pump. It is always functioning. It is throwing 3 sodium out and taking 2 potassium inside, and it is using energy. Because of this, all the time it is throwing sodium out and taking potassium inside. 3 sodium, loss of 3 sodium and gain of 2 potassium. Every time the cell is losing 3 plus ions and it is receiving only 2 plus ions. So there is a -1 ion is there. -1 positive ion is always. So inside of the cell will become negative all the time. This is the function of sodium potassium ATPase pump. Also, because of it is throwing 3 sodium out, there is always osmotic flow is created. Osmosis will occur because you are creating high and low concentration of sodium. Here is low, here is high, because this is outside, this is inside. Sorry. So concentration gradient is created. Electrical gradient will also be created because of loss of one positive charge. So these are the importance of sodium potassium pump. High osmotic pressure is created because of loss of sodium or loss of ions into the interstitial space. And because of that, protein and glucose are transported actively by the co-transport with sodium. I will show you the picture now. And chloride is always following the sodium. When sodium is moving out, or in, chloride will also be following because this is positive and negative charges.
Doctor,
Yes.
the previous image, I think at slide 6, maybe, it looked like facilitated transport.
In facilitated, remember, in facilitated diffusion, it will be from lower side of from higher to lower concentration, right? And it does not require energy. And it does not, and what is the third condition? So we can, it looks like to be facilitated, but it is occurring because of sodium potassium pump here. If you block this, this will not happen. Sodium will not move, glucose will also not move. So this is not diffusion. This is, or this is not facilitated diffusion. This is secondary active transport because it depends upon the primary. This
Can you
is
show us in the image, in the same
yes,
image?
yes. I will show you here. Maybe the coming is where it is. This was previous lecture. Okay. This is the image showing you that this is the intestinal epithelial cells, our intestine. This is a cell. This is the lumen. From here, the food is coming. Okay. The food which is high in sodium and high in glucose. You are eating. So that's why sodium and glucose enter into the lumen. Now, how it will be absorbed? It has to go from higher to lower concentration. But for that to move in, always there should be less sodium inside. Okay. If you want to throw sodium into the cell or glucose into the cell, there should be lower concentration inside. Now this lower concentration of inside is created by sodium potassium ATPase pump on the other side, back side or basal side. This is basal, or here it is written basolateral membrane, either basal or lateral membrane. There is a pump which is called as sodium potassium ATPase pump. This is always creating less sodium concentration inside because it is throwing sodium out, right? Because of this less sodium, the sodium will be moving from intestine to the cell. Because of this only, this pump. If you block this, sodium will be accumulated inside and less here. So it cannot move in. So this pump is creating a low concentration of sodium. That's why sodium is moving in. Whenever sodium moves in, this is a cycle which is having two seats. I gave you the example that it's a motorcycle. Let's say it's a motorcycle which is having one seat and another seat. This is a motorcycle. So if sodium only here, the motorcycle will not run. It has to have glucose also. When glucose is sitting on the other seat, then only it will function and it will cause movement of sodium and potassium, sodium and glucose inside. This is, both of them are moving in the same direction here, and this is here. So that's why it is called as co-transport. This is a type of secondary active transport, and the name is co-transport. Why co? Because they are moving in the same direction because of the sodium potassium ATPase. That's why it is secondary active transport. Did you get my point now?
Yes, doctor, thank you.
Opposite to that, secondary active transport could be of second type. This is called as counter transport. This is also a secondary active transport, secondary active transport. Why it is called as secondary active transport? Because the movement is taking place because of the primary. Because of the primary. What is primary? Sodium potassium ATPase pump. So sodium is, because every time sodium is 3 sodium is moving out, 3 sodium is moving out. So there will be less sodium inside. Because of this less sodium, on the other side, suppose there are high sodium here. So sodium will move in. And every time, again, this is a same like a what you call motorcycle. But the thing is that here, when sodium binds, calcium will bind, but will move in the opposite direction. It will not go in the same direction. One sodium is moving in, calcium is moving out. This is called as counter transport, counterclockwise. You know the counterclock position? This is a clock. It is moving in this direction. We can say clockwise position. If it moves in this direction, we say counterclock position, counterclock rotation, right? So opposite. Counter means opposite. Movement of any chemical in the opposite direction of the other. This is called as counter transport. And it is secondary active. Why? Because it is happening because of the sodium potassium pump here. If you block this pump, this is not happening. There will be no. Just this is the source. So primary active transport is making the transport of sodium and exchange of calcium. This is called as the secondary active transport, and the name is counter transport. Another example is, I will show you or draw it here. Maybe I will erase this. Or maybe I will draw it here. Another example of counter transport is very good example in the kidney. In the kidney, this is the lumen, suppose this is the lumen here. So body is producing hydrogen. Okay. Hydrogen is harmful because it is acid, right? So when the primary active transport is taking place, it is causing 3 sodium out and 2 potassium in. So making less sodium inside. On the other side, there is another pump, which is called as hydrogen sodium pump, which is absorbing sodium and removing the hydrogen. So hydrogen will be removed and this will be going into the urine. So acidic secretion will be like this. So acid will be removed from the body, from the kidney by counter transport. Why counter? Because sodium is moving inside and hydrogen is moving outside. This is called as counter transport. Exocytosis and endocytosis is very simple. They are bigger molecule. If they are thrown out, this is called as exocytosis. And suppose bacteria is coming into the body. This is the bacteria. And these are our neutrophils. Suppose these are neutrophils. So they will go near to the bacteria and they will engulf the bacteria. Here the bacteria will come. And in the next step, the bacteria will be inside. Okay. This is called as endocytosis. Endo. This is exocytosis. Removal, exit. So simple. Cell eating is the endocytosis, and release of chemicals or hormones is the exocytosis. See, these are the molecules are coming out. Same thing is shown here. This is how the thrown outside. Exocytosis. So summary of the whole 2 chapters is this graph, this table. Summary. This is the summary. What is diffusion? It's a passive process. It will be moving from down gradient, that is higher to lower side. No energy is required. No protein is required. Osmosis is also type of diffusion. It is passive, but here the specific thing is water. Water diffusion is called as osmosis. From higher concentration of water to lower concentration, no energy and no proteins are needed. Facilitated diffusion is, it is also passive process. It is a type of diffusion from higher to lower side, but specific transport proteins are required. Specific transport proteins are required and no energy is required. Proteins are needed. This is the facilitated diffusion. Active transport, it is active process because it requires energy. Where is this? Energy is required, protein is required, and specific molecules are required for transportation, that is pump, but specific in or out, depending upon the transporter. Transporter can throw from higher to lower or lower to higher because we are paying, we are using ATP's energy. That's why. So this is a summary of the 2 lectures. Here is the, from the book, it is given specific examples. Diffusion is diffusion of oxygen and carbon dioxide. Diffusion through the specific channels like facilitated is sodium, potassium channels or chloride channels. Osmosis is water only. Carrier mediated transport, facilitated diffusion. Here is the examples of glucose that is moving into the, it is a type of facilitated diffusion also, but it is secondary active transport like specific molecules, glucose. Another name for co-transport. Co-transport, another name is symport. Symport. Another name for counter transport is antiport. Another name, terminology is slightly different. Both the things, they require ATPs at the other site, sodium potassium pump. So here endocytosis and exocytosis examples are given. Okay. Anything you did not
Symport
understand?
is a co-transport.
Hmm?
Symport and co-transport are the same.
Symport and co-transport are same. Antiport and counter transport are same. Name in one language, or you can say terminology. When we say exit or exo, going out or exit is same. Coming in or inside is same. So like that. So terminology wise, co-transport is symport, counter transport is antiport. Okay. Let us see. Is the 1 second. Sorry. Okay. Sorry, our worker is here. No problem. So what we were seeing, I was showing here. Membrane transport, easy. You say cell membrane transport quiz answer. Click here. Start. What is the cell membrane composed of? What is this? Lipid bilayer. Where is the lipid bilayer? Phospholipid bilayer. Like this. This type of questions will come. See? Easy. So for everyone, should check some of the websites for practice. Maybe here. Just type whatever chapter name is there. Here, see here. Various examples are given. Gases such as oxygen and carbon dioxide crosses the cell membrane by passive diffusion through the lipid bilayer, primary active transport, specific gas transport mechanism, secondary active transport. What is the answer?
Passive
Ah.
diffusion.
Passive diffusion, very good. Carrier protein take part in carrier protein. Active transport, water transport, active transport of ions, passive transport of ions, none of these. Carrier proteins take part in what? Water transport or active transport or passive transport?
Active.
Active, good. Then, okay, here, which of the following is an example of primary active transport? Which of the following is an example of primary active transport? Here are the example. Chloride bicarbonate exchange, sodium potassium ATPase, sodium hydrogen exchange, sodium calcium exchange. Just now we have done.
Sodium, potassium.
Yes, very good. Now you know the questions. I am declaring the question online. Okay. See here, sodium pump. Sodium pump. No, we did not discuss. Which of the following values? We will come to that side. No. Okay. Endocytosis used by the cell. See here. Endocytosis to ingest the bacteria and cell debris, retrieve the elements of the cell membrane after exocytosis, secrete large molecules into the extracellular space. None of the above. Endocytosis.
A.
What is the answer? A, ingest. Very good. See, many questions are there. If you want to practice, same thing.
Dr.
Okay,
Rick,
coming.
even in carrier protein question, passive transport have encapsulated transport. Have a carrier
Okay,
protein.
these are the internet questions. We can guarantee from which book they are taking. But for us, similar questions will be there where there will be no second answer. Sure.
Yeah.
Okay. Yeah. Here you may be finding some problem related to what we have discussed just now. So I'm just giving you an example. But in our question, there will be clear-cut one answer. Quickly finishing the body fluids. Sorry, but it is taking too long time. What is mean by body fluid? Body fluid is the fluid present in our body. So water present in our body is amount, we call it as total body water. Total body water. We know that suppose I am a 100 kilogram person. Out of that, my body will have, as a male adult person, 60% will be water. Whenever we say any percentages, it is all depending upon young adult male person. Young adult male person, not for child, not for old age, not for female. Okay. In the books, every time they are mentioning some percentages, it is for young adult male person. Young adult means maybe around 30 to 40 years of age, not 10 years old boy or 2 years old boy or not 100 years old person. It is always, whenever we are mentioning, it is young adult male person. This is the common thing you must remember. So in the body, we have got 60% of water and 40% of other tissues. This 60% of water which is present, it can be present in two sides, inside the cell, or it may be outside the cell. Okay. Outside cells. We call it as inside the cell as intracellular fluid. The part which is present outside, we call it as extracellular fluid, ECF. ICF and ECF. These are the two parts of the total water. Okay. Out of this, 2/3 means if you divide the pizza into 3 halves, this part and this part, 2 parts will be inside the cell and only 1 part will be outside the cell. Okay. Extracellular fluid will be only 1/3. This is 1/3 and this is 2/3. 2 parts of the 3 parts total. Okay. Numbers, this 40 liters is not important because we have to remember in percentages only, these percentages. So out of 60%, 40% is inside, 20% is outside. Okay, remember this, extracellular and intracellular. Here it is showing 60% of the total body water will be divided into 40 intracellular and 20 extracellular. In extracellular also, you have got two parts, interstitial fluid and plasma. Interstitial fluid means the fluid which is present between the cells in the interstitial space here. And the plasma is which is present in the blood vessel. So extracellular fluid can be in the blood vessel or can be in the interstitium. Out of that, maximum is present in the interstitium and only 4% is present in the plasma. Out of 20, 16 will be here, 4 will be here. 16% and 4%. And very little amount of minor amount of fluid is present in transcellular fluid and lymph. Now, transcellular fluid could be in the eyes, that is intraocular fluid, or maybe around the brain, that is in the CSF, that is cerebrospinal fluid, or maybe in the joints, in between the joints, you have got some fluid here, that is transcellular fluid, and some part is present in the lymph. It is a vessel where a liquid is sucked from the interstitial space. So two minor compartment is lymph and transcellular fluid. Lymph is the fluid which is returning from the interstitium. These are the cell and fluid which is present here. It will be taken to the venous side by the vessel, which is known as lymphatics. So these vessels are called as lymphatics, and they will be going to the veins, directly merging with the large vein and draining there. Transcellular fluid is cerebrospinal fluid, fluid present in the eye or in the joint, or maybe around the lung. You know, the lung is covered by two membranes, which is called as pleural membranes, and there is a pleural cavity. So in the pleural cavity also some fluid, and around the heart also there is a membrane which is called as pericardial membrane, and pericardial fluid is there. So these are the areas where small amount of fluid is present. This is called as transcellular fluid. So this picture is very important because it shows you distribution of total body water. Out of total 100% of the body, you have got 67 intracellular, 33 is extracellular, and out of 33, 20% is plasma and 80% is interstitial fluid, and very little amount is present in the lymph and transcellular. Okay, why every person will have different amount of water? Why? Me may be having 10 liters of water, another person may be having 20 liters of water. Why? It depends upon gender, whether it is male or female, or upon age. How is the age? It is few years, maybe few months old, or few years, or maybe 100 years old. Depending upon that, the water content will be changing. But basically, it depends upon muscle mass. These are the muscles. So if you have more muscles, you will have more water in your body. If you have less muscle, you will have less water in the body. This is a general criterion. But specifically, the male or female will decide the amount of water as well as the age. How much is your age? But basically, the factor directly related is the muscle mass or protein mass. Anything which is having more protein or more muscle inside the body will have more water. Because the female has got slightly less muscle mass as compared to the male of the same age, they will have less water. And also with age, the muscle protein decreases. That's why the amount of water will be less at either the older person or maybe the child. So fluid is not mixing. Intracellular and extracellular fluid are not mixing because of the cell membrane, as well as some fluid which is present in the extracellular. It is present in the plasma in the form of it is separated by the blood vessel wall. So what are the, because they are inside and there are outside, there are specific thing present inside, specific chemical, specific ions, and there are specific thing present outside because of the barrier, because of this separation. What are these molecules present here? Please remember, this is also important slides to know, because this will be used every time in your further block, or maybe in the next lecture also. Same picture will be utilized and you have to remember it. What it says, these are the two extracellular compartment. This is intracellular. Okay. So within the intracellular compartment, what are the positive ions? Most important positive ion, see this much size, is potassium. This is ICF. So more potassium is inside. What is the negative ion inside? Most common is phosphate. This much amount. This much. PO4. This is minus sign. Anion. This is called as anion. This is cation. Cation is positive. Anion is negative. So inside the cell, most common positive ion is potassium, and most common negative ion is phosphate. Similarly, outside the cell, you take either plasma or interstitial. What is the most common positive ion outside? Sodium. Sodium is most common positive ion. What is the most common negative ion? Chloride. See, chloride. Please remember all these things. Which is the most common positive inside, which is the most common positive outside.
I'm sorry, doctor, can you repeat the slide?
The slide says this is the distribution of positive and negative ions inside or intracellular fluid and extracellular fluid. So in the intracellular fluid compartment, the most common positive ion is here, potassium. Okay. The most common negative ion is phosphate. Okay. Okay. Yes. No problem. No problem. Thank you. Done. So this picture shows which is positive, most common positive ion inside is potassium. Most common negative ion outside inside is phosphate. Similarly, extracellular fluid, most common positive ion is sodium, because it is more here, color, you can see the color. And most common biggest amount is the chloride, negative ions. Okay. Now get my point?
Yes, thank you so much.
This is difference between ICF and ECF. ICF has more protein, ECF has less protein, only protein is present in plasma. Intracellular fluid is having more potassium, extracellular and less potassium in outside the fluid, outside the the cell. Sodium is less inside, sodium is more outside. Phosphate is more inside, chloride is less, more outside. Same thing which we have seen in the picture. Why sodium is, now question is why sodium is more outside the cell? Tell me now. Why sodium is more up?
Sodium potassium pump or
Very
ATP.
good, because we have seen in the previous lecture that it is always throwing 3 sodium out and only taking 2 potassium inside. That's why sodium is more outside. Okay. Because of this imbalance, that is, something is more in, something is more out, it creates an osmolarity, that is, some concentration differences there. Okay, how the water moving why? What are the sources of water inside the body? We are taking inside the body water by drinking, by eating, and some are produced by some oxidation reaction in the body because of the carbohydrate metabolism, protein metabolism. How the water is going out? When we inspire or expire through our lungs, also from the skin, which is non-sweating like the palms or soles, where sweat does not come, but still it is losing water, and some with sweating, some with feces and urine. So these are the sources by which water is lost from the body. Here, this picture again, no need for remembering or memorizing the number. Just remember what are the sources of intake and what are the sources of output. If you know that water intake is by this and water output is by this, it shows 2600 ml is we are ingesting or putting into the body, whereas 2600 is we are putting outside the body by sweating, by urine. Where is urine? Urine is here 1.5, and by insensible loss. So that means input is equal to output. This is called as water balance. You know balance? Balance like this. So we are putting both in same amount inside and we are losing the same amount outside. This is called as balance. This is required for keeping the osmolarity constant. Osmolarity is 300 milliosmol. When you lose water, then osmolarity will increase. I will show you here. Yes, here. Normal osmolarity is around 300. If you lose water loss from the ECF, what will be its effect? Osmolarity will increase. Instead of 300, it will become 350 or 400. Give me any condition where you lose water. Give me any condition where you lose water from the body. No condition, you don't know anything where you lose water?
Like sweating.
Like?
Sweating.
Okay, sweating, excessive sweating. Okay, and?
Vomiting.
Vomiting, and?
Diarrhea.
Diarrhea, very good. So all these are loss of water. Water is lost. So tell me, if there is a water loss, what will happen to the osmolarity of the body?
Increase.
Increase to how much? How much it will increase?
More
Above
than 300.
300.
Yes, more than 300. Good. So if you lose water, the osmolarity will increase. Suppose if you don't lose water, maybe there is no water loss. If you are drinking, and there is no water is going out of the body, what will happen to the osmolarity? Quickly.
Will be decreased.
Become
What?
lower than 300.
Yes, lower than 300. It will become lower than 300. So if you lose water, the osmolarity will become hypertonic. If you gain water, these are the conditions. See here, these are the conditions given. If you gain water, so these are the signs of dehydration. Your skin will be dry, your tongue will be dry, your eyes will be sunken, going inside, and the brain function will be disturbed. You will be confused if you lose water. Similarly, if your body water is becoming hypotonic, the cells will become bigger, even the nervous tissue become bigger, and this will lead to again problem in the brain. But hypotonicity will not occur because you have got very special organ. What is this special organ functioning all the time?
Kidney.
Yes. So if kidneys are functioning properly, there is no possibility of hypotonicity. Only when there is a damage to the kidney. If the kidneys get damaged, you will be restricted for drinking water. Okay. So this is about renal failure is a condition where renal function is not there, kidneys are not functioning, and you will have more water in the body, which is called as water intoxication. Brain cells will become swollen. Isotonic saline. What is isotonic? Same. Iso means same than 300 osmolar. So there will be, if there is a dehydration, person will be given isotonic saline to maintain the volume. So in case of diarrhea, vomiting, isotonic salines will be given intravenously. Okay, that's it. Any question? Hi sawal, maafi sawal. So please, for practicing, just type the chapter and you will get the type of questions. Maybe you can type, instead of MCQs on transport, you can type body water, maybe. MCQs for body water or balance or something. You will get so many questions will come. But there are some which are not important or maybe not covered in your fluid and electrolyte and acid. No. So many chapters you can see. Mainly it is water and electrolyte together. Any question now?
No, thank you, doctor.
Welcome. So I will end the meeting now. Finish? No question.